With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with a question which says a galvanometer has a coil of resistance 100 ohm showing full scale deflection at 50 microampere. What resistance should be added to it so that it can be used as voltmeter having range 50 volt second and ammeter of range 10 milliampere? So first of all, let's try to understand the given problem with the help of a diagram. So here we have converted a galvanometer into a voltmeter, and next we have converted a galvanometer into ammeter. First of all, we have to understand the purpose of ammeter and voltmeter. Ammeter is a device which measure current, all right, and galvanometer is just a device which sense current, all right. So meaning is that galvanometer measures very small amount of current or negligible amount of current compared to that of ammeter, because its coil has very moderate resistance, we can say. So whenever a high amount of current, that is we have shown I over here, when it comes into the galvanometer, if it comes directly to the galvanometer, it will destroy or damage the galvanometer. So that's the reason what we do over here is we use a shunt resistance in with a galvanometer coil, so that the current gets divided in the path, and only that much amount of current passes through the galvanometer which it can sense, all right. And accordingly, this is how the galvanometer gets converted into ammeter, and which measure the high value of current as well. In the next case, when it gets converted into voltmeter, voltmeter is basically a device which measures voltage across 2 points, or we can say the resistance of our ideal voltmeter is infinite, and we can say voltmeter generally has very high resistance. So what we do over here is we put galvanometer in series with a shunt resistance, all right. Here it was the shunt resistance was in parallel, here it is in series, so that the effective resistance of the uh, galvanometer increases, and that's how it gets converted into voltmeter. So we will take one by one both the cases over here. So for voltmeter, first we will take for converting galvanometer into voltmeter. So according to the figure, first this is the first condition and this is our second condition. So for first condition we are talking, so here we can clearly see both the resistance of galvanometer and shunt both are in series, so we can say current will be same throughout both, and we can write voltage across total voltage, that is V, will be into Vg plus Vs. So this can be further resolved into Vg can be written as Ig into G. G, capital G, is resistance of galvanometer we have taken, and Vs can be written as Ig into S, and here it is V. If we divide the equation by G, Ig, we can say V upon Ig will be equals to G plus S. So from here we can say the value of shunt which we are interested in finding will be equals to V by Ig minus of G, and that's, if you substitute the value, V has been given as 50, Ig, that is current through galvanometer, is given as 50 micro ampere, so that is 50 into 10 raised to minus 6 ampere, minus G, that is shunt resistance, is given as 100. Galvanometer resistance, it's given as 100. So on solving, we can say the answer of shunt comes out to be 9999 into 10 raised to 2 ohms, or we can approximate it to 10 raised to 6 ohms. Alright, so this is how the shunt resistance should be used so that galvanometer gets converted into voltmeter. So this is the first part of the question. Now let's move on to the second part. So for second part, it's the ammeter case now. So for ammeter case, we can take it over here. So we can clearly see the currents get divided into the both, but as galvanometer and shunt both are in parallel, so voltage across galvanometer and shunt has to be same. So we can write voltage across galvanometer will be equals to voltage across shunt. Voltage across galvanometer can be written as Ig into G. Voltage across shunt can be written as Is into S. from here Ig has been given as, if you carefully analyze, Ig is given as 50 micro ampere, that is 15 to 10 raised to minus 6, and galvanometer resistance is 100, that is equals to Is can be written as I minus of Ig. From the figure it can be seen clearly total current coming is I and it gets divided into Ig plus Is. So Is will be I minus of Ig, and here it is shunt that we are interested in finding. So from this we can say 50 into 10 raised to minus 4 will be equals to I minus of Ig, that is 50, or total current coming is, we have to make it as 10 amperes, 10 milliampere galvanometer. So I is 10 milliampere, that is 10 into 10 raised to minus 3, minus of Ig is 50 into 10 raised to minus 6 into S. So on simplification we can say the value of shunt comes out to be 10 raised to 2 divided by 199. So this can be rewritten as 100 by 199, which is approximated to be as 0.5 ohms. So this much amount of shunt resistance has to be used so that galvanometer gets converted into ammeter. So this is the answer to the question is. So I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.